So good afternoon, everyone. Am I audible? Am I audible?
Yes, sir.
Okay, let us start session 2 of the day 2. So in this session, we'll discuss about two different type of normalization. Sorry, two different type of optimization technique. So yesterday we have seen genetic algorithm, we have seen simulated annealing and colony optimization, and today we have seen the use of optimization toolbox. So we'll see two different type of optimization which are very popular in last 1 decade. They are teaching learning based optimization. In short, we call that as TLBO. And there is another algorithm that is called as Jaya algorithm. In fact, these two algorithms are connected to each other. The improvement of TLBO is done in Jaya algorithm. So TLBO was discovered first. So after TLBO, uh, after they found that there is TLBO a little bit more complex, so they solved that using the Jaya algorithm. So let us see these two algorithms in detail so that you can understand that what is the significance of these algorithm, and you can implement these algorithm very easily. So what I'll do, I'll tell you TLBO theoretical part, as well as I'll tell you how to implement teaching learning based optimization and its implementation. Then we'll go for the Jaya algorithm, and I'll give an assignment kind of thing so you can implement the Jaya algorithm, because Jaya algorithm implementation is very easy in comparison to teaching learning based optimization. Okay, so we'll go for first TLBO followed by the Jaya algorithm. So both these algorithm, TLBO and Jaya algorithm, was proposed by Professor Dr. Ravi Pudi Venkat Rao. He is a senior professor, in fact, professor in higher academic grade pay, mechanical engineering department of NIT Surat. So he suggested these two algorithms. Prior to these algorithms, you can see genetic algorithm, particle sum optimization, and other algorithms are very popular. Yeah, Abhijit sir, please tell me. Abhijit sir, do you have any question? Is there any question? Okay. So he developed these two algorithms. First, he suggested TLBO in the year of 2011. After that, he again suggested another algorithm by making an improvement of TLBO, that is our Jaya algorithm. But both algorithms are population-based methods. So we have seen also genetic algorithm case also. We have taken initial population. Then with the population only, we apply different kind of operators. We applied reproduction, we applied crossover, we applied mutation. So all are applied to the population. Similarly, here also we'll take a population and we'll apply all the operations to that particular population only. And TLBO uses a population of solutions to proceed to the global solution. The objective of any optimization algorithm is to reach the global solution, right? So there is two phases in the teaching learning based optimization. First phase is called as teacher phase. Another phase is called as learner phase. So here learner means who is, you can say that who is the listener, or in this FDP I can say participant, or in a classroom I can say student. Okay, in general we say learner phase. So normally in a particular class, a teacher selects a particular topic and discuss about that particular topic, right? So every student is listening to the lecture or the content covered by the particular teacher. So that is called as your teacher phase, right? But in the learner phase, what happens when they reach to their hostel? or their residents. So let's say they are making pair. Okay, let's say one student is discussing the topic with another student. So they are doing interactions. So learners they are making pair and they are making discussion related to the topic. Okay, so that is called as learner phase. So in first phase, it is a teacher to all the students in a particular class. Okay, and in the second phase, the learners are making group. For example, if I can take this learner says 1, 2, 3, 4, 5, 6, then in the learner phase, let's say 1 is making pair with 5, 2 is making pair with 6, 3 is making with pair with 4. So first phase, teacher and student interaction. Second phase, learner-learner interactions. So learning by interaction between the learner. So these are the two phases that is there in the TLBO. Now, in order to understand it very easily, so there is we'll take a very simple equation, or we will take a simple example through a equation so that it is easy for you to understand. Once you understand this, then I'll show you its implementation. So here there is a function that is called as Himan-Blau function, and that function, this particular function takes two variables. One is x1 and x2, and it determines f of x1 and x2, which I represent as x vector. So what is f of x1 and x2? If you give the value x1 and x2 as input, then it is going to determine x1 square plus x2 minus 11 whole square plus x1 plus x2 square minus 7 whole square. Okay, just you need to give the value of x1 and x2, then you can calculate f of x1 and x2. And I told you every optimization problem you have a source space, right? So here the source space is given as -5 to 5. That means you can choose x1, x2 value in the range of -5 to 5. Somebody can say that x1 value is 1.01. Somebody can say x2 value is, let's say, 0.53. Okay. Another person can say, I'll take this is -4.39. Another person here will say 3.56. Okay. Like that, you can take a value for x1 and x2, but make sure that both x1 and x2 value is in the range of -5 to 5. Okay. And what is our objective? If I consider this is a function, okay, our objective is to minimize this particular function. So I already told you optimization objective is to either to minimize it or to maximize it. So here our objective is to minimize it. So if I get f of x value is less, then that is better. If a particular function is giving a minimum value, then I am going to accept it in the range of -5 to 5. So if you take this particular example and if you try to map it with teaching learning based optimization, so here the number of students we assumed in a particular class is 5. Okay, because we cannot take a class of 100 or 200 for illustration purpose, example purpose. So in real life you can take, but in order to go for easy understanding, so I have taken number of students in a particular class, that is 5. So number of student is also called as class size, also called as population size. Like if you remember yesterday, I have taken the number of population is 8. Okay, in most of the examples we have taken number of population is 8. So here I am going to take the number of population is 5. Okay, we represent it by a variable that is m. And we consider the number of decision variables. So for example, it is a teaching learning process. So every student is going to take some subject, right? Like in a particular semester, we know our students are, let's say, reading 5 subjects, right? Or 7 subjects, based upon our curriculum. So here I consider that they are reading only 2 subjects. Okay. So number of subjects is also called as number of decision variable, which we consider as n. So it is assumed here it is 2. So I am taking a very simple example with 5 different students and 2 different subjects. So if you understand it and if you can code it, So for any number of students, any number of subjects, you can generalize it. And like I mentioned in genetic algorithm, you should know what is the termination condition. Okay, after how many iterations you are going to stop, or you can put a particular threshold value until unless you reach to a particular threshold value, until unless you reach to that particular threshold value, you are go on iterating that. So in this case, I have taken the number of iteration is only one. Okay. And as I told you, the source space is -5 to 5. So if you take it in the form of a matrix, by taking, let's say, student number 1 and student number 2, student number 3 and student number 4, student number 5. And if I take this side, course number 1 and course number 2, then it just look like a 5 cross 2 matrix. Okay, 5 rows and 2 columns, where row indicates students and column indicates courses. Right? It might be different. You can say different variables you can give, but you have to ensure that whatever values you are putting here, all these values are in the range of -5 to 5. So generally, what we are doing, we are using a particular distribution. In mathematics, you know, there are different type of distributions are there, like uniform distribution is there. We can go for Poisson distribution, binomial distribution. A different type of distributions we have. So here we are using distribution as uniform distribution, because you know in MATLAB, if you go for random number generation, MATLAB follows uniform distribution to generate the random number. So initially we are taking the random number in the range of -5 to 5, as our source space is -5 to 5. Okay, if your source space is -10 to 10, generate the random number in between -10 to 10. Now, how to generate random number, that I'll show you in MATLAB code. So here, as I said, there is two different variable. One is x1, another is x2. Okay, we have two variable x1 and x2. So in order to find f of x1 and x2, you need a value of x1 and x2. So this serial number indicates student 1, student 2, student 3, student 4, student 5 respectively. X1 is a subject name, X2 is another subject name. Now, if I put X1 value, these values we have to generate, right? In the range of -5 to 5. Okay. So if I generate the values in the range of -5 to 5, so let's say the value it is coming as 3.2 and 0.403. 3.22 and 4.003, 4.03, sorry, 0.403. So what you will do, you have to calculate f of x1 x2. So if you calculate f of x1 x2, it is nothing but 3.22 square plus 0.403 minus 11 and its whole square, plus x1 is 3.22 plus x2 is 0.403 square minus 7 whole square. Right? So can anybody calculate and tell me what is the value we are getting? If this is our f of x1, x2, which is expanded as 3.22 square plus 0.403 minus 11 whole square plus 3.22 plus 0.403 square minus 7 whole square. How much you will get? Can you use your calculator or mobile phone calculator and tell me what value we are getting? So calculate one value at least. Yeah, what value we are getting here? Okay. Can anybody calculate and tell me? Okay, you will get the value is 13.139. What I mentioned here, 13.139 you will get. Okay, you solve this one. Already I have calculated. So I got 13.139. You may get little bit here and there, but all the values will come 13 point something. Now I have generated random numbers for
Yes,
also.
13.1392226.
Yeah. Yeah. Okay. Thank you. So for the second student, I have generated another two random number, right? One is for subject one, another is for subject two. Similarly, what I can do, I can write 0.191 whole square plus 2.289 minus 11 whole square plus 0.191 plus 2.289 whole square minus 7 whole square. Okay. So if you calculate this one, you will get the value is 77.711. Okay. Similarly, you can calculate for student 3, you can calculate for student 4, you can calculate for student 5. So you will get these values, these f of x values. So all of you please verify. Okay, if there is any mistake, please tell me. Okay, in later point of time. So now, if you look into the f of x value of 5 different students, which f of x value is better? Can anybody tell me which f of x value is better? Which f of x value is better?
First one.
First one. Okay. Because our objective is to minimize, right? If our objective is to maximize, the highest value we are getting in the student case 4, student ID 4. So definitely this is better. Okay, maximize case. But as the problem is minimize, the first one is always is better because it is less compared to other value. That's why if you remember, I told you, if I take a set A, which consists of set of element, let it be x1, x2, x3 up to xn, choose a value of x. Okay, let it be xi such that it is less than equal to all other values of x. Okay, all other values of x, which is where x is belongs to a set A. Yesterday I told you, right? Okay, so we got which one is the best value. Okay, now what we will do before proceeding to the next step of teaching learning process. So we have to find what is the mean of this particular subject. Like every teacher for a particular class, after we are awarding marks to our student, we are very much interested to find what is our class average. Okay, so we are finding the average of x1 and average of x2, and you know average of x1 is nothing but I'll sum all the values 3.22 plus 0.191 plus 3.182 plus 1.66 plus 2.214 divided by 5. So you will get the value is 2.093. Okay. So x2 case also you can do find the mean. Okay. So you will get the value is 1.697. Now, what you have to do? So after first step, what we did, we generate a set of random numbers, okay, based upon the our what is our student strength as well as how many subjects they have taken. Then we have calculated what is the f of x value. Then we have calculated mean of x1 and mean of x2. Then what we will do, we will calculate the difference in the mean for subject J. For every subject, you have to calculate difference in mean. What is difference in mean? Difference in the mean you have to calculate using this particular formula. So I am telling you this formula in a very simpler way. U indicates a random number in the range of 0 to 1. It is a uniform distributed random number followed by following the uniform distribution. That's why we are represented UJ. So we have two subjects. So we need two random number in the range of 0 to 1. So the first random number, assume that we got is 0.25. Another random number we got is 0.43. So every one case it may be different. Whenever we will go for the implementation, you may not find these random number. Any number may come in between 0 to 1. Now, you can see here I have written MJ. What is MA? MJ? MJ is nothing but mean of subject 1. This is the mean of subject 1. This is the mean of subject 2. You can note down here. 2.093 and 1.697. Whatever we got here, I have written in this column. Then here you can see I have written something called XJ star. What it indicates? The particular student where you got the best value. What is the corresponding X1 value and X2 value? For example, in this case, you can see 13.139 is the best value. So 13.139's corresponding X1 and X2 value is 3.22 and 0.403. So that value I have written here. So I think all the values, whatever I have written here in this table, that is clear to you. Now, we'll see what is difference in the mean subject. Difference in the mean subject, if I calculate for the first subject, I'll take the first random number, that is 0.25, this one. Okay. Then XA means I'll take the best value of X1. Okay, you will say best X1 and best X2. Because with that X1 X2 combination, you are getting a best value of f of X. So this X of J, it is nothing but 3.20220. Then this is called as TF. TF stands for teaching factor. Normally we take teaching factor as 1. Okay, we are considering TF is 1, but TF is calculated as round of 1 plus U. So if you generate this, U is again in the range of 0 to 1. The range of U is 0 to 1. So if you take any value, okay, for example, you are generating a random number, let's say 0.5. So if you add with 1, so it is 1.5. So when you go for round, it will go to the previous digit. Okay. Ceiling, if you do, it will go to the next digit. Floor, if you do, it will go to the previous digit, right? 1.5 floor, it is 1. 1.5 ceiling, it is equal to 2, right? So here also, even if it is 1.1270 or 0.5, if I take 0.5, it will come as 1.5. If I am taking 0.1270, we are getting 1.1270. So if you apply round, then it will be rounded to the previous one. It will not round it to the next digit, previous digit, previous rounded number. So that is 1. So always we are taking teaching factor is 1. Or if you want to define, then you write round of 1 plus U, generate a random number, add with 1 and apply round. So you will get 1 only, right? So now MJ indicates mean of the subject J. So here you can see Uj is the random number which I have taken 0.25. Xj is the best value of the first subject. I have taken 3.220. Teaching factor I told you I am taking 1 and mean of that particular subject is 2.093. So I am taking 2.093. So if you calculate this one, you will get 0.288 or 2818. So this is with respect to subject number 1. So now, without looking into this slide, can you tell me what is the value for 2? So I'll take random number, this particular random number, I'll write 0.43, that is my Uj. Then what is my Xj for the second subject, Xj star? So that is nothing but 0.403. Then minus, then TF is considered as 1. What is the mean of the second subject? That is 1.697. So I am writing 1.697. So if you calculate this one, you will get what is the difference in mean for subject 2. So here I have calculated. Also you can calculate, you will get the value is minus 0.5564. Okay. Is it clear how to calculate difference in the mean for subject 1 and subject 2? So you need 3 things. One is one random number. Another is the best value of X. Another is mean of a particular subject. With these 3 value, okay, if you consider teaching factor is 1, with these 3 value, you can calculate what is the difference in mean for subject 1 and difference in the mean subject 2. Is it clear? Or if you have any question, you can ask before moving to next slide. Okay, so I think there is no question. So why you are finding, somebody can say why you are finding difference in the mean subject. So difference of mean subject is calculated to update our population. You know, in genetic algorithm also, what we did crossover, we did mutation, then we update our values, right? So what I did here, so you know we got 0.2818 for the first subject, which I have written here, and minus 0.5564 for the second subject. So whatever population I have earlier, what is the population I have earlier? That is 3.2202, 0.403, and all other values. These 10 values. So that value in their corresponding subject, I have added 0.2818 for subject 1 and minus 0.5564 is added for the second subject. So you got a updated x1 value and x2 value. So generally we call that as a new x1 value and new x2 value. So new x1 value is calculated based on the old x1 value and what we have calculated, difference in the mean of the subject. Okay, so I am writing difference for the simplicity. Similarly, here I am writing old x2 plus difference in the mean subject 2. So that will give me my new one x1 and new x2. Now, using this new x1 and new x2, you can again calculate f of new x1 and new x2, right? F of new x1 and new x2, right? Then you can compare whether your old x1, x2 is better or new x1, x2 is better, right? For example, in this case, after adding the corresponding student's x1 value with the difference, you are getting the value is, let's say, 3.5018. If you add these two, you will get 3.5018. If you subtract minus 0.5564 from 0.403, you will get minus 0.1534. So this is your new x1. It is not your old x1. It is your new x1. It is new x2. What I can do? I can calculate f of x based upon this x1 and x2 value. Right or not? So if I calculate this one, how to calculate? Again, you have to take 3.5018 whole square. Okay, minus 0.1534 minus 11 whole square plus x1 case you can take 3.5018 plus x2 case I can take minus 0.1534 whole square minus 7 and its whole square. Okay, if you calculate this one, you will get the value is 13.3037. Okay, so now what is our old value? Our old f of x value we have calculated here, which is the best value, that is 13.139. So that I have written here. So now I am comparing my new f of x with my old f of x. Which one is better? New one is better or old one is better? Which one is better? New one is better or old one is better? Which one is better? New one is better or old one is better? So in this case, our old f of x is better, right? As old f of x is better, we are discarding our new x1 value and new x2 value. But if you assume that if new f of x is better, then we are going to replace the new f of x, x1, new x1, x2 value with old x1 and old x2 value, right? For example, if you look into student number 3, so this is the new x1 value and new x2 value. With this value, you are getting f of x as 12.7634. But what is the old value? Old value is 14.024. Okay, so in comparison to old value, new value is better because this is a minimization. So as new value is better, what I'll do? I'll discard my old population and I'll update with the new x1 value and new x2 value. Okay, so if new f of x is better, then new x1 and x2 value is updated. If that is not better, old f of x is better, we'll retain the previous x1 and x2. Okay, so this completes the first phase, that is called as teaching phase or teacher phase. Okay, so the next phase we know that is called as learner phase. But before going to the learner phase, let us implement the teacher phase. Okay, so I request all of you to open MATLAB. So there you can implement. Just a minute. All of you open MATLAB. I hope you have installed MATLAB in your system. So it will take a little bit time to open the MATLAB. Okay, now it is open. So what I'll do, I'll create a new script. So you can see there is a new script here. Okay, or in your system, it may show new file. So just create it, a new script. And let's say I want to save this file. Okay, click save and then save as. Suppose I want to store it in our workshop folder. Okay, under materials. Let's say I'm writing TLBO underscore implementation. Okay, so whatever I'm doing here, if you want to copy the code, you go to the material folder and copy it. So see here, in MATLAB, you can create a script and write it, and this in command window, you will get the output, right? So what I'll do, in this example, how many students we have taken? We have taken 5 students. So I'm writing students is equal to 5. And we have taken 2 subjects. So I'm taking subjects is equal to 2. Okay. So why I'm taking variable? Because later point of time, if you want to change the number of student to, let's say 10, or subject to, let's say 5, that you can do it, right? And in this particular function, if you see what is the limit given to us, the lower limit is given as -5 and higher limit is given as +5. So I can write lower is equal to -5 and higher is equal to +5. Okay. So whatever static value you are taking in your code, better to represent it in the form of a variable. So later point of time, if you want to change, you need not worry. Okay. And you can give a comment line in MATLAB by putting percentage symbol. Okay. So this is a comment line. So what I will do, first I need to generate a random number. So here you can see I have generated a random number of size 5 cross 2. It is if I take it is a matrix. So the size of this matrix is 5 cross 2. So what I'll do, I'll write a simply 2 for loop for I is equal to 1 to students or j is equal to 1 to subjects. Then let's say I'm generating population. So let me write population of I comma j is equal to, in MATLAB there is a predefined function that is called as RANDI, that is called as random integer function. So random integer function takes 4 parameters. One is lower limit and upper limit. So we have already represented lower limit and upper limit by -5 and +5 by lower and higher variable. So you can write here, first one is lower, next one is higher, and how many integers you want to generate. Okay, if you want to generate 5 cross 2, you can directly write 5 cross 2. But in this particular loop, I want to generate only one integer. So I'm writing 1 comma 1. So let me show you in command window. It will be more clear. Then we'll come to here. For example, I'm writing random integer. I want to generate a matrix in the range of -5 to 5. Okay. And I want to generate a matrix of size 5 cross 2. So note that -5 and 5 is the range of value you want to generate. 5 cross 2 is the shape of the matrix, right? So if you press enter, then you can see all these values are generated in the range of -5 to 5. But these values are integer values because this function is an integer function. That's why I'm saying RAND stands for random, I stands for integer. But what we need? In this example, we have taken real numbers. So in order to convert it into real numbers, there is another function that is called as rand, RAND. So if I write rand, then it will generate a random number in the range of 0 to 1. So for example, if I again generate a random number, so it is generating a random number in between 0 to 1. So what I'll do here, so in each iteration, if you want to generate one random number, so it will come as an integer number. This function is returning an integer. So if I multiply it with the random function, so it will convert it into a real number. Then every for loop you have to write end to terminate in MATLAB. So then you have to write end. So I have terminated both the loop. Okay. But you can see here there is a red mark. What it says? It says that variable population appears to change in size. So in order to be safe side, what you can do, you can write create a population, okay, population variable with all values are zeros and the dimension is 5 cross 2. Okay. Or you can say the dimension is students and subjects. So whatever matrix you want to create, first it will fill with 0. So there is no issue in generating the population. So there is no change in size. You have specified the size of the population here. Yeah, up to this it is clear. Yeah, anybody is having any question?
Sir.
Okay. So if I run this code, so let me run this code. If I run this code, it is asking me to change folder and add path. So better to write add path, so it will add my path. So it is adding my path. Then if there is any error, it will be showed here in the command window. You can see this is the my file name, and it is not showing any error. That means it is working fine, right? And you can see in the workspace, whatever variables you have taken, that is created, right? You have taken higher, you have taken lower, you have mentioned student, you have mentioned subject, and you have some population. So if I open population, so I am getting a matrix of 5 plus 2. Let me go to my PPT. In PPT also we are getting a 5 plus 2 matrix. So here also we are getting a 5 plus 2 matrix. All these values are in the range of minus 5 to 5, right or not? All these values are in the range of minus 5 to 5. But we are not getting, okay, any value. We are not getting the value which we have shown in the slide, right or not? Whatever value it is showing in the slide, it is not showing. Even if you are executing TLBO implementation, that is our file, again, you may get another set of values. Values will vary because this is random number. But in order to uh, show the same result, in order to check that whether the same value what is given in the slide, we are getting the same value, what we can do, we can fix this particular value. Later point of time, whenever you are executing it, you can generalize it. But I want to reproduce the result that is given in my slide. That's why I am taking, let's say, these set of values. So for that, what I have to do, I can simply write here, I'll comment this one. Okay, that is of not required, right? In fact, this total loop is also not required. You can simply write, okay, let me comment all the loops. The comment is R, control plus R. So this loop is not at all required if you want to take the some static value. So I can write population population is equal to 3.220, right? Next value is 0.403. Okay. Semicolon indicates it is the end of a particular row. Then 0.191, 2.289, then 3.182, 0.335, then 1.660, then 4.593, and the last one is 2.214 and 0.867. Okay, so if I execute it, then if I go to my workspace, if I open it, you can see the values which I have written here, the same value is produced here as I have copied the value, right? So let us do the calculation with this value. Once you are comfortable with this one, you have to comment this particular line and make this on comment line is comment line as on comment, right? Make this particular line as comment line and these 4 lines as on comment. Okay, so that it will run for any number of students, any number of subjects, right? So now what we will do? Now what is our first step? Our first step is to find the value of f of x, and we will find the mean of x1 and mean of x2. Both things we have to find, and this process is we have to iterate multiple times, right or not? Until unless our termination condition is satisfied, we have to do it. So I can say for, let's say I am taking a loop variable k, so it will run for number of iterations. So let me define the number of iterations. In this case is, you can specify, let's say I am specifying 2 or 1, you can specify. For example, in later case, if you want to change it to 20, 30 also, you can do it. So now, what do I have to do? I have to find the mean, right or not? So in order to find the mean, I'll write a loop for I is equal to 1 to students. Okay. For j is equal to 1 to subjects. So check here, see here how to calculate mean. I will take all x1 values divided by 5. So I am taking for I is equal to 1 to student, j is equal to 1 to subject. If I want to find mean of j is equal to mean of j plus these values are available in population, right? So I am writing population of I comma j. So that will add all the values. It is not calculating mean. It is adding all the values and keeping all the values in the mean of j. Okay. So after the end of this loop, what you can do? If you say for the first student, it will run for all the subjects, right? I'll take students. I is the student, j is the subjects, right? So per subject, okay, first you are adding all the values. Okay, after adding these values, then what I'll do? I'll divide by the particular subject, right? So once you calculate this one, then I can write j is equal to 1 to subjects. I'm calculating mean of j is equal to mean of j divided by students. So here we are calculating sum of the first column, and sum of the second column. Here what I am doing, whatever sum I have divided it by number of students, right? So I am getting the mean. Here you will get exact mean. Here you will not get mean. It is only aggregating all the values. That is, you can say sum. Okay. So again, you can see if you put a cursor here, it is showing the variable mean appears to change in size on every loop. So in order to avoid this one, you can write mean is equal to zeros of 1 and subjects. So how many means you will get? You will get 2 means. That's why I'm taking a matrix of 1 cross 2. 1 cross 2 will keep only 2 values. Okay. So now you have calculated the mean. So what else you need to find here? We have to find f of x value. Right? This is our f of x value, right? We have calculated 13.139. So this value you have to calculate. So for this, what you have to do? you have to calculate for I is equal to 1 to student, because for every student you will get a fitness. So I can say fitness of I is equal to, what is that function? That function says that x1 square. Where I will get x1 square? I kept everything in this population matrix. So what should I write here? I should write here population of I comma 1. I comma 1 means first it will start with 1 1. 1 1 means 3.22, right? Multiplied with, because it is square, x1 square. So I am taking population of I comma 1 multiplied with the population of I comma 1, right? That you have to calculate first. Let me put in a bracket. Okay, so that you have to calculate first. Then you have to add with the function says that x2 minus 11 square. So I can say plus population I comma 2 minus 11. Okay, population of I1, I comma 1 into I comma 1. Okay, it is going to make population x1 square. Population of I comma 2 you have to add and minus 11. So that will give you the first part. Similarly, what is the second part? Second part says that x1 plus x2 square minus 7. So what we'll do in this case, plus population of I comma 1. Okay, that is our population. Okay, but it is saying x1 square plus x2 minus 11 and its whole square, right? It is not x1 square plus x2 minus 11. It is its whole square. So what we will do? This part you have to take twice. So I can write multiplied by this one. Okay, that will give you square. So this is x1 square plus x2 minus 11. Okay, this is another x1 square, x2 and minus 11. So we want square as a part of Himalaya function. So this is solved the first part. Now what we will do? We have to similarly go for second population. Okay, let me write here. Then I can make backspace so that it will come in the same line. So, so otherwise you can split it. If it looks very complex, you can split it. Okay, no issue. So I can write population of I comma 1. Okay, what is the second part? Second part is x1 plus x2 square minus 7. That you write first. Then you put the same term. So that will make square. So let me write. This is my x1 that is available in population I comma 1 plus population of I comma 2, right? Multiplied by again population of I comma 2. Okay, let me put in a bracket. This one is a bracket. Okay, because first we need to compute that. Then minus 7. That is x1 plus x2 square minus 7. Okay, then what you will do? You have to multiply with again the same term. That is population of I plus 1, I plus 2 and population of I comma 2 and minus 7. The same term. Okay, so that will give you the whole function. Produces a value that might be unused. Okay, let me check this. Okay, leave it. So this is my fitness value, right? So if it is correct, then it is going to calculate fitness of each and every student. Okay, so now let me terminate this particular loop by writing and it is over. Okay, so let me close the loop here and check that whether our code is correct till now or not, right? So again, you can see fitness case also it is saying that the loop variable is changing. So I am writing fitness. Fitness you are calculating. Okay. For how many students? You are calculating for 5 students, right? So fitness is also I am taking a zeros of 1 and students. So it will create a array with 1 and students, means 1 cross 5 matrix where all the values are put as 0. Okay. So in MATLAB, if you skip the semicolon, that will be displayed. That particular statement value will be displayed in the command window. So if it is correct, so let me see whether it is correct or not. Yes, it is correct. So what I should expect? I should expect the mean value. What is the mean value we got here in slide? 2.093. So we got 2.093. What is the x2 value we got? That is 1.6974. So mean case we have written correctly. Another is you have calculated the fitness. What fitness value you got in this slide? So here you got in the first student case 13.1392, second student case 77.711, third student case 14.024, fourth student case 261.57, and fifth student case 43.6412. So are you getting the same value here or not? Are you getting the same value or not? So if you want, I'll share this code in your chat box, our chat box also. So you can copy also if you want. Although it is available in our folder. Okay. So all the code is not coming. It is coming up to mean of J. So what is that mean of J? 1, 2 subjects. Okay. Rest one. Okay. So whatever we got in this particular slide, we got the same value. What is our next step? Our next step is to go for difference in the mean subject, right? But before going for the difference in mean subject, you should know which one is providing you the best value. Okay, whether student 1 is giving value, best value, or 2 or 3 or 4. So for that also we need to write a loop. So let me write a loop. For I is equal to, that should be inside this one, not outside. Okay, for I is equal to 1 to 1 to will go for students, right? So I will check the fitness. You know everything is written in the fitness. We have taken an array. We got 5 fitness of 5 different students. So I have to choose one of them is the best fitness. So what I can do initially, let me create a best fitness here by saying best fitness is a very bigger value. Okay. So whatever value you will get, if that value is less than this one, okay, yes, you are comparing here, fitness of I is less than best fitness. If it is true, then it is going to replace this particular value. That is, best fitness is equal to fitness of I. Like in the first case, we know we are getting 13 point something, right? 13.139. So if we compare 13.139 with this large value, okay, then what value will get? We'll get 13.13 only. 13.13 less than is equal to 99999. Okay, so obviously which one is smaller? Fitness of I. So best fitness is equal to fitness of I. And not only that, we need the best fitness index. Okay, so I'm writing best fitness index is equal to I. Because with that index only, you have to find what is the corresponding value of x1 and corresponding value of x2. Okay, let me close these statements and loops. Okay, it is closed. Okay, up to this, we have completed whatever given in the first slide and we have selected which fitness is better. So if I run it and if I show you my workspace, in workspace you can see best fitness index is showing 1 and best fitness is showing 13.1392. Right? Now what is our next step? Our next step is we have to go for difference in the mean subject for subject 1 and subject. How to find this one? Using this particular formula. So if I write this particular formula in MATLAB, then it can solve my problem. Let us try to write that one. So let me comment here by saying that the difference in mean for subject. So here onwards, we are writing the code for difference in mean for subject. So let's say for j is equal to 1 to, so we want to find mean of the subjects. For j is equal to 1 to subjects. Okay. So what I will do here, I have to find difference of subject j. Subject 1 I have to find, subject 2 also we have to find. How to find this one? I will generate a random number. Go to the slide. You can see the slide. We have to generate a random number, that is uj, right? Then multiply that random number with xj star. Xj star is nothing but you will find xj star in the population two-dimensional array by taking best fitness index. So best fitness index is our 1 in this case, right? So population of best fitness index comma j. Okay. Then you have to subtract with the teaching factor. I can write teaching factor as TF, right? And if you want TF to specify, you can specify here TF is equal to 1. Or if you want later point of time a higher value, that also you can give. But normally TF is equal to 1. Okay. Then what you have to multiply with TF? TF is multiplied with the mean of that corresponding subject. The corresponding subject is J. Okay. So this will give you the difference in the subject. Okay. So obviously, what we have here? Here also it is changing the values, right? DIFF, it is changing the value. So let me write here DIFF is also, I'm initializing with all zeros so that you will not get any issue. Zeros, 1 and subjects. Okay. So that will give you the difference in the subject. But if you execute it, what value you are getting in DIFF? Let me see. DIFF you are getting 0.1341 and minus 0.6451. But in slide we are getting a different value. What value you are getting? 2818 and minus 5564. Why you are getting different value? Can anybody tell? Why we are getting different value? Here we are getting 2818. Here we got 1341. Can anybody tell
Due to
me
the
why?
random function.
Exactly. So you have generated these values randomly, right? Correct. Randomly. So in order to avoid this one, what you can do? Okay, you will do like whenever you go for implementation, definitely you are using this one. But here, as I am showing, regenerating the result, whatever given in the slide. So let me comment this thing. Okay, or you can write like this by initializing these random numbers, whatever we have taken. So I think we have taken 0.25 and 0.43. So let me take here with a variable, let's say random number is equal to 0.25 and 0.43. Right. Then what I'll do, I will comment this one, which you can later use if you require. And if you want to make it static, so instead of random function, I am writing random number. Random number 1 comma j. So there is 2 random number required, one for subject 1, another for subject 2. So 1 comma j, population of best index j, and TF into mean of j. So now you run it, check whether we are getting the same value or not. Yes, we are getting the same value. that is 0.2818. Here we are getting, I think, 2817. Okay. Here and there you will get in the third and fourth digit. And minus 0.5566 you are getting, here you are getting 64. Correct. So now this part is also done. Then what we did? Whatever value we are getting is the difference of the subject, that we need to add, right? So that we will get new x1 and new x2 value. So let us do that one. So go to MATLAB. After finding mean of the subject, what you have to do, I can write for I is equal to 1 to students, students. For j is equal to 1 to subjects. Okay, so new population can be generated. New population can be generated by taking the old population and adding this difference in the subject. Okay. So again, new population, it is saying that it is changing. So better, what we can do, we can write here new population is equal to zeros of. So we'll fill it with the matrix with all zeros, so that this type of problems will not solve. Although sometimes also it is not causing any problem. So better to fill it with zeros, so that we are in safe side. Okay, so new population also I have created. So let us run it, check that we are getting the same population or not. So if I go to new population and open my slide, so I think I'm getting 3.5017 minus 0.1536, it is matching. 0.4728, 1.73 matching. 3.46 minus 0.22, it is matching. 1.94, 4.03, 2.49 and 0.31, it is matching. Okay. So now what do we have to do? We have calculated it, but we need to calculate the fitness with respect to new x1 and new x2. So I will get a new fitness value. Then I will compare the new fitness value with old fitness value, or new f of x with the old f of x value. So let us do that. So what I can do here, for I is equal to 1 to students, I have to calculate new fitness. So new fitness of the student I. Okay. So simply you can copy this line, right? You copy this particular line because you have calculated for population, right? The same way it is applicable for new population. Okay. So instead of writing population, what I'll write? I'll write new population. Okay. Earlier you have calculated for population. So now we are calculating for new population. So just I am changing the variable name here is new population. So that this particular statement is going to find new for new population. Otherwise, you can break down it. If it is a long one, you can break down. But I have written in one statement, that's why it looks very complex. Okay, so it is done. Okay, again, new fitness case, it is creating problem. Okay? So better we'll also declare for new fitness. I think we have declared for fitness. Just let me copy this line and paste here, and I am writing new fitness. Right, the problem is solved. Now we got new fitness, right? So if you execute it, you run it, then if you open new fitness, we are getting 13.3015. You can notice here. Next value we are getting 94. Then you are getting 12. You are getting 136 and 39. So new f of x also you have implemented. So the next process is you have to compare the new f of x with old f of x, or the new fitness with the old fitness, to know that which one is better. Like in genetic algorithm also we did. We compare the parent 1 with the modified children 1 or parent 2 with modified children 2. Okay, because population size is not increasing. Population you can replace, its performance you can replace, but you are not increasing or decreasing the number of population. So just I'll do the comparison. So what is the comparison here? So just you calculated the new fitness. So take a simple for loop for I is equal to 1 to students. Okay, then if new fitness of I of a particular student, let's say I starts 1 to 5. If it is greater than the fitness of that student, okay, this is new fitness. If new fitness is better than the old fitness, okay, otherwise you can write less than. Okay, otherwise you can put greater than, you need not do anything. If new fitness is more, because it is a minimization problem, right? So if new fitness is coming more, then old is better, right? But if fitness of new fitness is better in comparison to fitness, that means new fitness is less than fitness of I, what I can do, I'll write fitness of I is now going to be updated with new fitness of I. Okay, and the corresponding x1 x2 value also you have to take. So I'm writing for j is equal to 1 to subject, as I have two subjects. Okay, so I can write population of ij we need to update with whatever new population we have for that particular student. Okay, so see here what I did. I am checking whether old population is better. This is your new population, right? New fitness is better. Yeah, old fitness is better. So in this case, we know new population is better. So what I am doing, I am replacing these two values. I'm taking these two values and replacing with 3.184 and 0.335. So that is done with this one. Okay. So if you execute it, you press F5, it will run. Now, if you go to population, these are population. Yes. So you can see population is now updated. So let me go to the slide. So this is the updated population. Yeah, I think little bit it is changed. Let me check once. Second case it is coming. Third case it is not coming. Fourth case. Where is that code? Okay, if 1 to students, if new fitness of I is greater than fitness of I, fitness of I is equal to new fitness of I. For j is equal to 1 to subject, population of ij is equal to new population of ij. Okay. Okay, the problem is that we have executed it for 2 iterations. We make it 1 iteration only. Because till now we have not started second iterations. I think now you should get this value. If I'm correct. Yeah. So now you can see we are getting the value as 3.22, 0.40, 0.1910, 2.2890, 3.4237, 0.22, and 1.94, 4.03, 2.49, and 0.3. So we have successfully implemented the first phase of TLBO. Right? Now what I'll do, I'll go for the second phase of TLBO. Okay, I'll go for the second phase of TLBO. Okay, so let us see what we are doing in second phase. In the first phase, I told you a teacher is teaching in the class and all the learners or the students, they are listening to the teacher. So that phase is completed, right? In the second phase, learning phase, one learner is to interact with another learner. So they have to make pair. Okay. So for example, these are the student IDs 1, 2, 3, 4, 5. One has make a pair with 2. 2 is make a pair with 5. 3 is make a pair with 1. 4 is making pair with 5. 5 is making pair with 4. So not necessary this is disjoint. For example, you can see student number 2 and student number 4. They are making pair with the same one, that is 5. That is also possible. Okay. So whatever value we got in the previous iteration, based on the best value of our f of x that we are taking, and making a pair. Each and every learner has to make a pair with others, and duplication is allowed. So now we'll see when one is interacting with 2, then what benefit we are getting. Okay, let us see here. So this is the population of 1. This is the x1 value of 1 and x2 value of 1, and this is also this is also the x1 x2 value of student number 2, because the interaction happens between whom, 1 and 2. So their corresponding value which I have written here, I have copied to here, including f of x value. Okay. Now when one is interacting with 2, assume that in a particular class 2 students are interacting. So you can say one is knowledgeous, another is, let's say, not that much knowledgeous as the first person. So when they interact each other, one may benefit, one may not benefit also. Okay. Okay, one may benefit, one may not benefit also. We cannot say that always interaction is successful. So after interaction, we are going to update some value. Update the x1 value and update the x2 value and calculate the f of x value. If f of x value is better, then we can say interaction is successful. If f of x value is not better, then definitely we can say that no, this interaction is not successful. So see here, how to make updation. Updation is done using this particular formula where u indicates a random number in between 0 to 1. So, so when you go for first one, first subject, so I am taking the previous value of the student number 1, that is 3.22, plus random number is 0.47, and the difference between these two students, that is 3.22 minus 0.1910. So you got the value is 4.6436. Now, if I take for subject 2, your current value for the student 1 is 0.40. Why I am taking student 1 here? Because student 1 is interacting with student number 2. Student 2 is not interacting with 1. If I write like this, it indicates that student 2 is interacting with student number 1. Okay. So now 0.40 plus another random number, that is 0.33, and difference between these two subjects. Okay. So if you calculate, you are getting minus 0.21, minus 0.21. Okay, minus 0.2194. So now you got a new x1 value and new x2 value. Put into our f of x or f of x1, x2. Okay. So if you put that, you will get the value is 112.3816. Okay. If you put 4.6436 whole square plus let's say minus 0.2194 minus 11 whole square plus 4.6436 plus minus 0.2194 whole square minus 7 whole square. So if you calculate this one, then you will get the value is 112.3816. But what is the value before this interaction? That is 13.1390. That is a good value in comparison to 112.3816. So what we have to do? We will discard. Even if this interaction happens, we can say this is not a successful interaction. So there is no improvement, right? So we retain our old solution, right? Similarly, what is our next interaction? Our interaction is interaction of 2 with 5. So we we will take x1, x2 value of 2 and x1, x2 value of 5. So let us see here. We have taken in 2 and 5. How to update? I can take 0.1910, a random number, and difference between these two. I am getting minus 0.8923. Similarly, for the second subject, 2.2890 plus 0.33, a random number, and difference between these two. So I am getting 2.9419. Okay. So when I am calculating f of x using this particular function, so I am getting the value is 53.3166. But what is our existing value? Okay, existing value is 77. But now with this interaction, you are getting the value is 53. Which one is better? The interaction value is better. So we say that it is a successful interaction. That means when the two learners are meeting each other and they are discussing, there is a fruitful discussion, we can say, right? So we are retaining the new solution and we are discarding this old solution. We'll replace this old solution with these two solutions. Similarly, you have to make a interaction between 3 with 1, 4 with 5, and 5 with 4. Okay, so I am not showing everything here, and I have also not given in the slide also. So after doing this one, you will get these are the updated values. Okay, if your previous value is better, you keep it. If the new value is better, you take the new values. So once you have done this thing, this interaction is done. 5 interactions will be done. Okay, 1 will do 1 interaction, 2 will do 3, 4, 5. After 5 interaction, one of the iteration is over. So if you see this, the output of this particular iteration, before this iteration, our best value is 13.1390. But after this interaction, we found that our value is improved to 12.3875. Like that, in couple of iteration, you will see whatever may be the optimum value, the value will be very close to that particular value. Okay. So this is the process that we followed in teaching learning based optimization. So if you have any question, you can tell. Otherwise, I'll show you the implementation part of learning page. Yeah, if anybody is having any question, you can ask. Okay. If there is no question, let me go to my code and complete it. So I have shown you the process of teacher phase, but now we have to go for the process of learner phase. So let me write here. This one is my second phase as a comment. So later point of time you can understand. And let me write here. This is my first phase. First phase. Okay. Okay. So what I'll do here, I have to make pair. So for each student, I have to create a pair. So I'm taking a for loop for I is equal to 1 to student. So a pair is created. Pair of I is equal to, you have to generate a pair, and pair is a random number. It is not a real number. So I can write 1 to students and 1 comma 1. So it will make a pair. This code will help me to create a pair. 1 to student means you can pair with 1 to 5. You cannot make pair with the student which is not there in the population. And at a time, it is going to generate only one value. So this loop is going to execute for 5 times and it will generate 5 pairs. And 1 will pair with the corresponding value and 2 will pair with the corresponding one and so on. Right? But if I do this one, again, whatever result I am getting in my slide, I may not get the same result. So I am making it a comment line. So later point of time, if you want, you can use it. So what I'll do, I'll write here pair. Pair. Who has made pair with whom? So if I go to this particular slide, so I told you 1 is paired with 2. So let me write 1 is paired with 2, then 2 is paired with 5, 3 is paired with 1, 4 is paired with 5, and 5th is paired with 4. So 25154, that I am writing here. So that the same value we can generate. Okay. So now we have to make interaction. How to make interaction? We'll use this particular formula, right? Xpj double dash is equal to Xpj single dash plus Uj Xbj single dash minus Xwj single dash. So let me write for I is equal to 1 to students. Okay, let me see the formula and write here. Okay, I am creating new population here. So new population of I comma j you can create. New population means here I am talking about Xpj double dash is equal to our old population. Old population we have kept in population of I comma j, right? Plus random number. Again, if you use rand function, any number can come, right? In order to avoid that, I am taking some static random number. So we have taken two numbers here. One is 0.47, another is 0.33. So let me write random number 1 is equal to 0.47 and 0.33. Yeah, Abhijit sir, please tell me. Yeah, Abhijit sir, if you have any question, you can ask. Okay, I think there is no question. Okay, so 0.47 and 0.33. But normally you have to take rand, right? Then, okay, let me write for normal one. Then I'll write for a static code. New population of I comma j is population of ij, and rand function, which is going to multiply with whom? It is going to multiply with population of I comma j, right? And the interaction, right? The population of I comma j means I am talking about the first population first, then second population, then third population. But it has to interact with one of the pair, right or not? Is there any question?
Excuse me, sir.
Yeah, madam, please tell me.
Sir, in the small doubt, sir.
Yes.
Actually, you have used the function minimize function, right?
Yes.
So in that function, they took the values like x square plus something xj minus 11 whole square.
Yes.
That is the
Yes.
formula. So
Yes.
in what base they consider the values 11 and 7 in that, sir? Is there
No,
any
no.
specific?
This is predefined, madam. This is a
Okay.
standard
Okay,
function.
function itself, it held
It
the
is a
value.
standard function, madam. In mathematics,
Oh,
every people are using this standard function.
okay, okay, sir. Okay,
Yeah.
thank you, sir.
Yeah. Yeah. Any more question? Okay. So what I am doing here, I am taking population of ij. I am multiplying the random number with population of ij and pair. Right. I have to find the difference between them. So population of I is making pair with pair of I. Okay, that is pair of 1 comma I, because I am taking it is a one dimensional matrix. I am writing 1 comma I, then comma j. That will give you the interaction value. Okay, so once interaction value is done, so this will give you two value. Yes, one is for I need two values. One is for, okay, I need two values. So I need to put another loop here, right? For j is equal to 1 to subjects. Because for the first subjects also you need to update value. Second subject case also you need to update value. You see here, they're calculating the first subject. They're also calculating for the second subject. So you need a loop for your subject also. The new population of ij is equal to population ij, random number, and this one. Okay. So let me close this loop. Okay. Or if you want to put a static value, then you can make it comment, and you can use our random number, which I have used here. Random number 1 comma j. Okay, I think a random number I have used 1, I think. Okay, random number 1. Okay, So this is a generalized one and this is a specific case, right? Which I have taken in my slide. Okay. So then after that, what happened? You have calculated the new population, but you need to find new fitness also. So new fitness can be calculated. New fitness of I is calculated using this one. So this is the fitness formula, right? Which we have already used. So simply I am copying this formula. Okay. So let me put paste here. Right. So now I got new fitness. After new fitness, what I will do? I will check that whether new fitness is better or old fitness is better. So for that, let me check here. If new fitness of I less than, okay, if you take greater than, you need not do anything, right? If value is coming very higher than your old value, you have to not do anything, right? Okay. If new fitness value is bigger, then nothing to do anything. But if this value is not better, then what you have to do? You have to replace your new fitness value. You have to take and replace with the fitness of I. New fitness of I. Right. And its corresponding x1, x2 value also we have to take. So I am writing for I, for j is equal to 1 to subjects population of I comma j is equal to new population of I comma j. Okay. Okay. You should check that the same number of and you have to write, otherwise it will show an error. Okay. And after everything, you have to increase the number of iterations. Iterations is equal to iterations plus 1. So until unless you reach to the predefined number of iterations, this loop is going to run. But I have restricted the number of iterations as 1. Okay. So anyhow, we have not, okay, 1 to number of iterations. So what we can do here, so anyhow, we have written number of iterations, right? It's going to run, no problem. If you want to know the number of iterations, you can write another variable, iterations is equal to 1. Okay. So let me run this thing. And if there is no error, I think whatever given in the slide, we should get that one. So see, let me close the code. See, for the interaction between 1 and 2, interaction between 1 and 2, we have not succeeded because our f of x value is very large, right? So there is no updation. So you are getting 3.22 and 0.4030 as usual, right? But when you interact with 2 with 5, so the interaction is successful. So the updated value, that is minus 0.8923, you can see here. And this x2 value 2.9419 you will get here. Similarly, you have to make interaction between 3 with 1, 4 with 5 and 5 with 4. Okay. So you will get what? You will get these values. Okay. So after completion of the first iteration, you can notice here, if you go for fitness, which one is the best fitness here? 12.3826. So in slide also you can see we got the best value is 12.3875. Here and there it will be there in the third and fourth digit. Okay, so if you run it for more iterations, for example, I want to run this code for 10 iterations. I'm making number of iterations is 10. Run it. So it is successful. Let us see the result. You can see the fitness is now coming as 4.7, 4 point. All are coming close to 4 except 1. So the best value we got is 4.0588. Make it 100 iteration. I'm just showing you how the values are decreasing. If you go for 100 iterations, let me check the updated value. Okay, what is our fitness? We are getting same fitness for this one. The value of iterations. 101. Okay, that means it is working. So after 100 iterations, why the value is not changing? It should change. These values should change. Okay, let me try with 50 iterations and see whether the value is changing or not. Earlier it is changed for 10, right? So number of iteration I'm taking 20. So I think after some iteration, you are not getting any improvement. So you have seen that in the previous case, when I change it to number of iteration to 10, the value is changed. But after that, I don't know why it is not changed, but it should change the value. The fitness value is coming after 8 iterations, but why it is static? Number of iterations 1 to 10. Okay. New fitness is coming very large value. The fitness. So I think there is a error here. That's why the performance is not increasing. The is working. 11 is coming, correct.
Sir,
So,
is it due to that we have commented out the random parts? That's why.
no, that is okay. That is one of the reason, but it should work, right? Irrespective of that, also it should work. That you are right. But we have not fixed anywhere, right? How many iterations? We are writing number of iterations only. So if I am changing here, it should change here also. Okay. Population it should calculate. Random number case, it's okay, but you can take any random number. Where also you can make random. Okay, whatever you are saying, let me try that one also. Control U on comment. On comment. Let us make it enable, make it visible. Then what else? Here, let me take this one. I'll make comment this one. Save on comment. Right? So let me try. So is fitness increasing? Let me check fitness. Yes, you are correct. But okay, I'm not able to identify. I'll check it once. But whatever you said, that is correct. After changing it, what you can see the best fitness is coming 1.1067. So let me increase the number of iterations to let's say 20. Okay, in 20 case, what is the best fitness we are getting? We are getting the best fitness is 0.1246. Means every iteration the result is changing. But I think we have taken some static value. That's why it is not coming. Whatever you pointed is correct only. But still I'll cross check. Yeah, you can see after 30 iterations, all the fitness is very small only. So when you go for 50 iterations, you can see all values are in single digit. If you go for 100 iterations, again, values are very small. So after a couple of iterations, you will find all the values are very close to the optimal value. Okay. So this is the implementation of TLBO. If you have any doubt, you can ask. Otherwise, I'll go for the next algorithm. Yeah, this is the algorithm you can see for TLBO. As I mentioned, first you need to specify what is the population size. You need to put a termination condition where we have taken here the number of iteration, and you can mention the number of decision variables. Decision variables are nothing but our subjects, and population size is nothing but our students, right? And iteration count starts from I is equal to 1. Okay, what we did here, we calculate the mean of the subjects, right? And we calculate the difference in mean, that is D of J. As you have taken 2 subjects, we have calculated 2 difference in the mean for 1 and mean for 2. Then in the teacher page, what we are doing, whatever DJ we are adding, we are calculating here, that DJ we are adding with the corresponding subject. Okay, we are adding D1 to all the D1 to the subject 1, D2 to the subject 2, right? And if new solution is better, you are accepting it, otherwise you are rejecting it. Similarly, in the learner page, what we are doing, we are making a pair with another learner. So 1, 2, 3, 4, 5, as we have taken 4 different students, they are making pair with another student, right? And we have updated the new value after interactions, and we check that whether new value is better or old value is better. If new value is better, we are replacing it. If old value is better, we are retaining it, right? And this process we are repeating until unless our termination condition is satisfied. Okay. So this algorithm we have used for TLBO. Yeah, anybody having any question? Okay. Then I'll tell you the next algorithm, which is a very simple algorithm. That's why I spent more time in TLBO. So Jaya algorithm is very simple, and Jaya is a Sanskrit word. The meaning of Jaya is victory. It was also proposed by Professor Venkat Rao, right, from SBNI Surat. So the problem with TLBO we have 2 pages. One is teacher phase, another is learner page. But in the case of Jaya algorithm, we combine both pages into a single equation. You know, there is 2 different equations we have used. One is for the teaching phase, another equation for learning phase. Now, in this algorithm, you have we have combined both into a single equation. So this algorithm tries to get closer to the success, that means close to the best solution. On the other hand, it is avoiding the failure, that is away from the worst solution. Okay, like as a student in a class, a particular student should observe the good student or the topper of the class. So he is closing to the topper of the class. At the same time, those people who are not performing well, from those students, it should be that particular student should be away. So you have to close towards the solution and away from your failure. Then there is a faster convergence, right? So both algorithms are called as algorithm specific, parameterless algorithm. There is no specific parameter used. As you have seen in equation, we are not using any specific parameters. The major difference is TLBO uses 2 pages and Jaya uses 1 page. So which equation we are using, that I am telling you here with all mathematical notations. So like every optimization algorithm, we are taking f of x. This is our objective function. Our objective function is either to minimize or to maximize, right? And we consider m number of design variables, and our design n number of design variables and n number of candidate solutions. So these design variables are nothing but our subjects, and candidate solutions are nothing but our
Sir,
yeah.
I've been listening to this and I wanted to ask when you say teaching learning, we are also talking about other scenarios where there is optimization, like in game theory.
Optimization like game theory means what
In
you
within game theory, when we talk about the Nash equilibrium, so
huh.
can instead of just set data sets out there, when one win one loses, that is zero sum, instead of that I can actually apply uh, either Jaya algorithm or TLBO for those for coming to a state, or maybe a model of a cricket team where the cricket team is learning continuously, like in Jaya algorithm, both phases are both phases will be happening simultaneously.
Yeah, if any particular application where you want to get closer to the best solution and away from the worst solution, there you can apply Jaya algorithm.
Yes, sir.
Yeah. Again, but we have to check, right? Because we have to go through the literature. Maybe somebody has already applied this algorithm in a respective field.
I will check, sir.
Yeah. So here we are taking n number of subjects and n number of n number of students, right? And this is the simplest formula that we are going to use for our Jaya algorithm. Okay. So what is x? X is our current value. Xn is our new value, right? And R1, R2, it is our random number. XB is the best value. XW is the worst value. So every population should be close to the best value, away from the worst value, right? So B is considered as the best solution. W is considered the worst solution. So if you can take this particular equation, then you can easily implement the Jaya algorithm. So like you have seen, I have written around 50-60 lines of code in the case of TLBO, but this can be easily implemented with 20-30 lines of code because there is only one phase. Okay, so let us take the same example. Okay, so I am taking here 5 different students and I am taking 2 different subjects. Okay, and again my source space is given as -5 to 5 like previous case. So I have generated some solution. Our initial population we have generated, right, in the range of -5 to 5. Then we have to calculate f of x1, x2, right? So if you calculate f of x1, x2 using this particular formula, so you know how to calculate. Still I am telling you 3.15 square plus -4.02, okay, minus 11 whole square plus x1 is 3.15 plus minus 4.02 whole square minus 7 whole square. So if you calculate, you will get the value as 177.53. Similarly, if you take these x1 and x2 value, then you will get corresponding f of x value. But in previous case, what you are doing in the case of TLBO, as it is the objective is to minimize, you only focus on this part. Right, out of these 5 different students, you select the best student. But as Jaya algorithm says that get closer to the best student and away from the worst student, so you have to consider the best value as well as the worst value. Right, you can see out of these 5 value, which one is the best value? The second student. Which one is the worst value? The fourth student. So whatever calculation you will do with respect to the second student and fourth student. Now you can see here. So how this interaction will be done? In the previous case, I said interaction, right? One is interacting, one candidate is interacting with others. So the process of Jaya algorithm says that, for example, I am taking student 1, 2, 3, 4, 5. So they are part of they are belongs to a particular class. Who is best among these students? The best is always 2. Which student is worst among in the class? The fourth one. So the formula which is given here, which I told you, in which you need best, worst, as well as the current one. That's why I am taking a pair like this: 1, 2, 4, 2, 2, 4, 3, 2, 4, 4, 2, 4, 5, 2, 4. Where 2 is the best solution for entire class. The topper of a class is topper for everyone. And the person who secured the less mark is secured less for everyone, right? If you compare any student, you will get, so the we will take 3, 3, 1, right? The current student, best student, and worst student, and we will put in that formula so that we will get new x1 value and new x2 value. So let us see where here I am taking 1, 2, 4. So whatever x1, x2 value is there for 1, 2, and 4, I am keeping in this table, including the f of x value. Okay. So now in this particular formula also, you can see there is two random number. So I have to generate two random number. In this case, I am taking the random number is 0.68 and 0.74. Right. So now, how to calculate updated x1, x2 value or new x1, x2 value? So you have to take the current value. Let me write here. Current value is 3.15. So you can put this particular formula so that you can understand. X is my 3.15 plus one random number. I am taking 0.68. So this random number may be anything. For example, I have taken 0.68. Then best value. What is the best x1 value? That is 4.06. So I am taking 4.606 minus your current value. Current value is 3.15. Okay. Then minus R2. R2 is a random number. So I am taking, let's say the random number is 0.76 because I took two random number for x1 and two random number for x2. So I am taking the second one is 0.76. Then which one is the worst value? If you look into the x1 value of all these three population, that is 4.13. So I am taking 4.13 minus our value. Our value is 3.15. So this will give you the updated x1 value. Similarly, x2 case, what you will do? Minus 4.02, 0.74, best minus worst, right? Then another random number, that is 0.39, worst minus your current value. Best minus worst, sorry, best minus current, worst minus current. So you will get, let's say the value we are getting here, for x1 you are getting 3.02, x2 you are getting minus 8.86. So if you put in this Himalblau function, so you will get you are getting the value 5668.5098. But what is your current solution? The current solution is 177.53. So obviously current solution is better than the updated solution. So we are discarding this new x1 and new x2 value, and we are retaining the old x1 and old x2 value. Is it clear? So always you compare, wherever you are getting the good fitness, you have to take that one, right? So now what I have to do? I have to go for 2, 2, 4 now. I told you 1 is 1, 2, 4. 1 is my current population, 2 is the best population, 4 is the worst population. Now I am going for 2, 2, 4. 2 is my current population, 2 is the best population, and 4 is the worst population, right? So here what I'll do, 4.06. I'm taking random number is 0.68. Then best minus current. So it becomes 0 because here you are getting 2, 2. That's why you're getting 0. Then second random number is 0.76. Then worst minus your current. So you will get the value is 4.0068. Right. Similarly, in the x2 case, you will take minus 2.22 plus random number is 0.74. Best minus worst. So it becomes 0. Then again you have to take another random number 0.39. Worst difference between worst minus the current. You will get the value is minus 6.4260. So if you calculate the fitness value, you are getting the fitness is 1468.7923. But what is your current fitness? 14.60. Which one is better? Old one or new one? Obviously, old one is better. So I am discarding these x1, x2 value. I am not going to make update. Similarly, if you make 3 with 2 with 4, 4 with 2 with 4, and 5 with 2 with 4, you will get this set of values. You can see this part. This is our new values. These are old values. Obviously, first two case I already shown you. We are retaining the old values. But when you go for 3 to 4, 3 to 4, okay. So you are getting new value is 1.31 fitness, but old value is 121.89. So obviously you have to take the new one. You have to replace with the old one. Similarly, when you go for 4 to 4, you are getting 34.39. Obviously, it is better in comparison to 440. So you are replacing it. Then when you go for 5 to 4, in that case also, you are getting 139.67. So you are replacing with the old one. Okay. So this completes one iteration. So in the previous case, you are doing one iteration in teaching, one iteration in learning, then only overall iteration is over, right or not? But in this case, it makes very easy. It is very easy, right? So only with a particular formula, we make the update and we can take a decision. So you can see, if you look into this, this is our initial solution or initial population. This is the population after the first iteration. So what is the best value? It is 14.60. But what is the best value here? That is 1.31. So there is a drastic improvement here. So when you go for a couple of iteration, you will get the value close to the optimum value. Okay. So you can do couple of iteration in the case of Jaya algorithm. Okay. So Jaya is very simple. That's why I'm not showing you the implementation part. Okay. But I already shown you very complex one. So I request all of you, as a part of exercise, you try to implement Jaya algorithm. It is a simple function. You use two loops and function, you can easily implement. It is only 20 lines of code. Hardly it will take half an hour to do it. Okay. And if you are interested in reading more about Jaya algorithm and TLBO, you can refer these two papers. I think this paper is for Jaya and this paper is for TLBO algorithm. Okay. It is published in Distance Science Letter. I think it is under Elsevier and this is under Springer. You can refer these two papers by Professor R. Venkat Rao. Okay. Thank you.